In this section, we're going to go ahead and talk about the quadratic formula. So, the quadratic formula is used when factoring is not possible. It is used for solving quadratic equations. In order to solve problems using the quadratic formula, we want to be able to understand how to evaluate expressions with multiple variables, understand our order of operations, be able to simplify square roots, and finally be able to simplify fractions. We don't have time to derive the quadratic formula, so for all intents and purposes for now, we're going to go ahead and treat it like it's magic. Quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, where a, b, and c come from ax squared plus bx plus c equals 0. So in order to use the quadratic formula, the first thing that we want to do is we want to move all terms to one side and write in descending order, just like we did when we talked about solving using factoring. We want to plug the values into the formula. From there, we want to use order of operations to simplify inside the square root. If possible, simplify the square root using the techniques that we learned in the previous chapter. And then, if possible, simplify the fraction. If the square root simplifies completely, you want to separate it into two problems, one with the plus sign and the other with the minus sign. If not, divide each term by a common factor, if possible. For the square root term, you only divide the outside number. If we look at example A, 2x squared plus 9x minus 5. The first thing that I want to do is I want to go ahead and identify my a, b, and c. A is equal to positive 2, b is equal to 9, and c is equal to negative 5. You want to make sure that you keep the signs with the numbers. Let's write down our formula again. We have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. What we want to do is we want to use our tools for evaluating expressions by plugging in 2 for all of the a's in our expression, 9 for b, and negative 5 for c. So if we go ahead and do that, let's see what we end up with. We have x equals minus, b is 9, plus or minus the square root of 9 squared, minus 4 times a is 2, and c is negative 5. All over 2 times 2. From here, we want to go ahead and simplify inside the square root using order of operations. We get x equals negative 9. I'm going to leave everything outside the same. Plus or minus the square root of 9 squared is 81. Minus, or actually plus, we want to multiply negative 4 times 2 times negative 5, giving us positive 40. Note that we do have two negatives being multiplied, so it will end up being a plus. We can also multiply the bottoms. We get 2 times 2 is 4. We can finish simplifying inside the square root Inside the square root, 81 plus 40 is 121 over 4. (121) is a perfect square, so we can go ahead and simplify the radical completely, or simplify the square root completely. We get -9 plus or minus 11 over 4. Now this is an example of the first type of problem that I talked about in terms of simplifying the fraction. Since our square root did simplify completely, we want to separate this problem into two different problems. The plus or minus is basically a shorthand notation for saying -9 plus 11 over 4 or -9 minus 11 over 4. If we look at the first one, the first thing I need to do is add the numerators together. We get x equals -9 plus 11 is 2 over 4. And then we can simplify the fraction by dividing the top and bottom by 2, giving us 1/2. Or, in the second one, we can combine -9 and -11. Since they have same signs, we're going to add to get 20. We keep the negative sign, and we divide by 4. And we end up with x equals -5. So this problem has two solutions. They are both rational. We get x equals 1/2 or -5. This problem actually could have been solved using factoring. I think we can all agree that factoring would have taken up a lot less room. One of the benefits of, or one of the things to keep in mind when talking about factoring versus quadratic formula is that quadratic formula is very procedural, meaning all you have to do is plug in the numbers, and granted it may take a little bit longer, but you will get to the correct answers. Another issue that we have in terms of why would we want a quadratic formula, remember that when we talked about factoring, we did mention that not everything factors. We can have something called a prime polynomial. But in terms of solving equations, you will always have a solution. It may not be nice solutions, but you will always have one. And so when we talk about things that cannot be factored, we can still use quadratic formula in order to solve. This is going to be seen in example B. Example B, we have 2x squared equals 6x minus 1. Remember that regardless of whether you are using factoring or the quadratic formula, the first thing that we have to do is we do need to get everything on one side and set it equal to 0. So I'm going to subtract 6x and add 1 to both sides. I want to make sure that I write in descending order, so we get 2x squared minus 6x plus 1 equals 0. This is one that does not factor, and so the only way to solve it is using quadratic formula. So let's go ahead and identify our a, b, and c. A is equal to a positive 2. B is equal to -6, and C equals 1. Another thing to note is when you plug into the quadratic formula, make sure that you do not have any variables. All we keep is the coefficients, the numbers. Variables will not be seen inside the quadratic formula. Now that we have our values for A, B, and C, we can go ahead and plug them in. We end up with x equals minus a -6, where the minus sign comes from the original formula, and the -6 comes from our value of b. From there, we want plus or minus the square root of, make sure that you put -6 inside parentheses because I do want to square the entire -6, minus 4 times 2 times 1. We have that all over 2 times 2. Let's go ahead and simplify. If we simplify, we get minus -6 becomes positive 6, plus or minus -6 squared is going to be a positive 36, minus 4 times 2 times 1 is 8, over 2 times 2 is 4. We can finish simplifying inside the square root. If we go ahead and subtract, we get 6 plus or minus the square root of 36 minus 8 is 28 over 4. Square root of 28, even though it's not a perfect square, we can simplify it. And I'm going to come off to the side to do that. So square root of 28, remember that what I want to do is break this up into a square and a non-square. Well, 4 is a square and it does divide into 28, and our remainder would be 7. So we can split this up into the square root of 4 times the square root of 7. Let's bring it back over to our problem now. We get x equals 6 plus or minus, what is the square root of 4? We should end up with 2. We keep the square root of 7, all over 4. My last step is to simplify the fraction. You can either factor out a 2 from the numerator, or if you want, what you can do is just divide each term by 2. 6, if we divide by 2, we get 3. 2 square root of 7, if we divide by 2, we get 1. And 4 divided by 2 is 2. So our final answer is 3 plus or minus 1 square root of 7, or just square root of 7 over 2. The last thing to note is on the homework, they may not want you to use the plus and minus symbol. And so, unfortunately, the only other way to write this is 3 plus the square root of 7 over 2, or 3 minus the square root of 7 over 2. This would be it if we listed them separately. On paper assignments, if you write the plus and minus symbol, everyone understands what that means. It's just a computer thing, and as I said, I'm not entirely sure if it will accept plus and minus, plus or minus, or if you have to write it in expanded form. I would suggest that you look at a similar problem or a help me solve just to make sure that you are inputting your answer in the correct format. Let's look at one final example together. We have x squared plus 4x plus 1. Again, this one does not factor, and so we would have to use quadratic formula. We get a equals 1. If there's no coefficient, remember it's implied to be a 1. We get b equals 4 and c equals 1. We have our quadratic formula again. And so if I go ahead and plug in these values, I get x equals minus b, which is 4, plus or minus the square root of b squared, which is 4 squared, minus 4 times 1 times 1, all over 2 times 1. We can simplify inside the square root, and if we do that, we want to start with the exponents. 4 squared is 16, minus 4 times 1 is 4. And in the denominator, we get 2 times 1 is 2. Let's go ahead and subtract inside. We get negative 4 plus or minus the square root of 12 over 2. The square root of 12 does simplify. It's not a perfect square, but we can break this up into squares and non-squares. So square root of 12, or just 12. A square that goes into 12 is 4. Our remainder would be 3. If I take the square root of 4, I get 2 square root of 3. So let's plug that back into our problem. We get negative 4 plus or minus square root of 12, we said was 2 square root of 3 over 2. This we can go ahead and simplify. Again, you can either factor out a 2 from the top, or we can cancel a 2 from each term. 4 divided by 2 is 2. 2 divided by 2 is 1. And 2 divided by 2 it's still 1. So our final answer, we end up with x equals minus, don't forget your negative, 2 plus or minus 1 square root of 3, or just square root of 3. And since our denominator canceled, we don't have to keep it. This is the answer that most people will accept. If it's in your My Math Lab, you may need to write it as negative 2 plus the square root of 3, comma, negative 2 minus the square root of 3. When we talk about solving quadratic equations, there's 3 cases here that you're going to run into. You can have one solution, you can have 2 solutions, and with 2 solutions, they can either be rational or irrational. The first example where we could have used factoring, those were examples of rational solutions. Here, the last 2 examples are examples of irrational solutions. They are not nice numbers. Your final possibility, and you will not see it in this section, is no solution. You would get no solution if you ended up with a negative number inside the square root. Remember that having a negative number inside the square root, we said, meant that it was not a real number. Since we are solving now in the real number system, if you get a negative number inside the square root, then your answer is no real solution.